Within our solar system, one object dictates the physics of everything else. A thermonuclear furnace holding 99.8% of all matter in our cosmic neighborhood. Humanity has walked on the solid dust of the moon and driven rovers across the craters of Mars. Yet our own local star remains entirely out of reach. Approaching it means confronting two absolute laws of physics: temperatures that vaporize any known spacecraft, and gravitational forces that crush whatever remains. Surviving a journey into that plasma requires pushing material science past its current limits. To cross the most hostile boundary in our solar system, we must build an entirely new category of machine. Standard aerospace engineering fails at these distances. A ship built from titanium or aluminum would liquefy and boil away millions of miles before even reaching the solar atmosphere. This is the Soul Rider Eye. This schematic shows our primary defense. The exterior hafnium and tantalum carbide shield blocks thermal radiation. Beneath that, a diamond aerogel matrix dissipates 4,000-degree heat. Finally, an active liquid nitrogen loop maintains a stable 22-degree habitat for the crew. The entire mission relies on this extreme thermodynamic paradox, a fragile room temperature bubble encased within a burning shell. The descent begins. As the spacecraft drops past the orbit of Mercury, the immense mass of the Sun begins to visibly warp the local gravitational field. For the first phase, the crew manually steers the vessel, navigating through the unpredictable magnetic storms that lash out from the star into deep space. As the plasma density increases, the shifting magnetic fields begin moving faster than human biology can react. To avoid being torn apart, the crew transfers flight control to the onboard AI. At 5 million miles from the surface, we cross a terrifying milestone. We enter the corona, the Sun's outer atmosphere. The physical environment is incredibly violent. Billions of tons of supersonic charged particles are continuously battering the hull, creating vibrations that threaten to shake the ship apart. This is a crushing, turbulent ocean, an environment possessing the raw kinetic violence to physically tear a spacecraft into pieces. To escape the worst of the convection currents, the AI executes a tactical dive into a sunspot, a vast, dark canyon that looks like a puncture wound on the star's surface. Inside this depression, the temperature falls to a relatively cooler 5,500 degrees Celsius, providing the outer shields a brief, critical reprieve from the heat of the corona. But the canyon is volatile. Beneath us, immense magnetic field lines are constantly twisting and coiling until they finally snap under the extreme pressure. This image captures the result of that magnetic snapping, a solar flare. These explosions launch high-energy radiation straight out of the canyon and deep into the solar system. These localized magnetic events dictate the space weather for every planet we know. They are the chaotic engines that determine the safety of our entire solar neighborhood. The mission timer hits 0. The AI fires the main thrusters, fighting the Sun's gravity to pull us back into the vacuum of space. The roaring fury of the solar furnace fades, replaced by the quiet, cold isolation of the outer solar system. Looking back at Earth, the contrast is stark. We live in a delicate climate, floating in the dark and entirely dependent on the violent mechanics of the star we just witnessed. Every ocean current and every breath we take exists solely by the grace of this magnificent, terrifying engine. We are composed of stardust, forever tethered to the fiery origin of our own creation.